Okay, so in this way we get this equation, okay, is equal to 0. In order to hold this equation true, this coefficient of x power m should be equal to 0. So it means that what we can do is m plus 1 a m plus 1 minus am should be equal to 0. So in this case, now we can represent it like this: am plus 1 term is equal to, we take am on this side, am over m plus 1. Okay, so we can now represent this term. So therefore, if for example the value of am is 0, so it will be a0 over this. So in this way, let's try to find the coefficients. So for example, what is the purpose of doing this? So we need to calculate the coefficients of the power series. Remember that the power series is this. Okay, so we need to have these values a0, a1, a2, a3, etc. Okay, so we can iterate these terms and to find the values. So for this, maybe we can do it in the form of a table. Okay, so can draw a table. Okay, and then the value of am plus 1 we can calculate. So we can take different values of m. So for example, starting from 0, so we will get a term which will be 1, a1. Okay, and then similarly, if we just expand, I just expand that table. Okay, so 1, 2, 3, 4, maybe some more, 5, 6, or maybe 7. Yeah, it's just our choice. So if I take this, so I will get from according using this formula, maybe I can write it over here. Am plus 1 is equal to am over m plus 1. So if I use this formula, so with m is equal to 0, I will get a term a1. With m is equal to 1, I will get a term a2. So there similarly a3 equal to, and then a4, and similarly a5, a6, and a7. Okay, and then a8. So I will get these terms. So what will be a1 term? A1 term will be then a0 over this. So it will be a0 divided by this, and the next term will be a1 divided by this. Okay, then the next term will be a2 divided by, then a3 divided by, then a4 divided by. Okay, so in this way I can complete table like this: a6 divided by, and a7 divided by. Okay, a7 divided by. So what is divided by? Divided by is m plus 1. So 1, and then a1 is equal to a0. Okay, a1 is equal to a0. So a2, and then I can just write the next term as 2, 3, 4, 5, 6, 7, 8. Okay, like that. So now since a2 is equal to a1 over 2 and a1 is equal to a0, so I can put like a0 over 2. And now a3 is equal to a2 over 3, so it is a2 is now a naught over 2, so it is a naught over 2 into 3. Okay, let's not multiply at this time. So similarly, this is a3 is equal to a naught over 2 times 3, so it will be a3 over 2 times 3 times 4. Okay, and now this will be sorry, it will be a naught over 2 times 3 times 4 times 5, right? So we can see that a pattern is emerging. Okay, a naught into 2 times 3 times 4 times 5 times 6, and then so on. I think these many terms are enough. So what we get over here is, so we can get these terms. Okay, so the function of x, that is in fact in this case y, the series is a naught plus a1 x plus a2 x square plus a3 x cube, and then so on. So now we can input these values. So a naught is, we can take as a naught we can take as a naught. That means a naught is an arbitrary constant, but all the other constants a1 are also in terms of a naught. So therefore the next constant is a naught, okay, x, plus a2 is a naught over 2, a naught over 2 x square, and then the next one is a naught over 2 into 3. So what is 2 into 3? 2 into 3 is actually 1 into 2 into 3, which is 3 factorial. Or similarly, this 2 is actually 2 factorial. So what we can write over here is that a naught over 3 factorial and x cube. And then what is a3? a3 is yeah, that was a3. Okay, a naught, and then that's it. So you can see that the next one will be a4 x cube, a4 x4, a4 x4. So a4 will be a naught over 2 into 3 into 4, that is actually 1 into 2 into 3 into 4, it is 4 factorial. So we already know the pattern now over here. So what we can do is we can take a naught as common, so it will be a naught 1 plus x square over 2 factorial plus x cube over 3 factorial plus x power 4 over 4 factorial, and so on. So what is this term in the bracket? This term in the bracket is the Maclaurin series for e power x. So we get the solution as y is equal to a naught e power x, so which is the same as we already know. So so this means that this power series method works. Okay, so we can easily find the so not very easily, it's a little bit time consuming process. We can find the solution in terms of the series, and for those known solutions we can even verify those solutions. So in this case then that means we can verify the solution for the given differential equation y prime minus y is equal to 0. We already know solution, but we have just verified it. That means the power series method works. Okay, so we can also apply it to other cases. Okay, so now let's solve another differential equation, y prime plus 2xy is equal to 0. So this equation can also be solved by direct method, by separation of variables like this. So log of y is equal to minus x square, and e is equal to c e power minus x square. That is the solution. Okay, that will be the solution, c e power minus x square. So this solution we already do. So let's see whether we can get the same solution by the power series method. So for remember that for the power series, we can represent y prime and y as like this. So y prime we can represent by this summation or sigma notation, and m is equal to 0 to infinity, and earlier we have used it, this one. Yeah, we have used it. M is equal to 0 to infinity, m plus 1, am plus 1. Okay, and then x. M is equal to 0 to infinity, m plus 1, a m plus 1, x power m. Yeah, and then this one for y is like this. And then in this case, plus 2xy. So plus 2x, and then for y, m is equal to 0 to infinity, and then y it was am x power m, and then that is equal to 0. So this is the differential equation in the sigma notation form. Okay, so in this case we need to simplify it. For example, we can take 2x inside of this sigma notation. So m is equal to 0 to infinity. This is m plus 1, a m plus 1 x power m, and then sigma m is equal to 0 to infinity. So 2 will be here, and then when x will be then multiplied by x power m, so it will be a m x power m plus 1 is equal to 0. So now we can see that this is the term m plus 1. If we take it, if we bring it back by 1, so then what we will get, x power m over here. So here we can see that in these two sigma notations there is a difference. So in order to combine the terms of these two sigma notations, the powers of x should be same, and these index values should be also same. So what we can do is maybe it will be better to work in the powers of x to the power m. Okay, so in this case what I can do is I can decrease its power of m. Okay, so x power m, and then it will be a power m minus 1. Okay, m plus 1, and then it will be m minus 1. Okay, and okay, so if we move from x power m plus 1 to x power m, so this am will be m minus 1, and then 2 will be 2, and then what will happen to this sigma term? So sigma term, sigma term is containing these index values. So when index value will actually increase, because if we decrease from here, the index value will increase, as I have also explained before. Okay, so if we increase the value over here, then the index value should decrease accordingly. Okay, so with this change, what has happened is that now we have bring x power m, and x power m is common, so that is no problem. But now we have changed the index value from m is equal to 0 to m is equal to 1, so which is not the same as the index value over here. So therefore we have to make some changes over here in this term as well. So this was m. So for this, we will continue it in the next video clip.